The last thing that we need to be able to do is solve equations by first using properties of logarithms. Okay, so looking at problem number 11, I have two logarithms on the left, one on the right, so I don't have a logarithm equal to a logarithm, so I can't use the property of equality yet. So what I need to do is I need to condense. Okay, so first you want to look for any coefficients, pull those in as exponents. So right here I have a 2 that can be pulled in as an exponent, and a 1/4 that can be pulled in as an exponent. So the first step here is going to be log base 3 of 6 squared minus log base 3 of 16 to the 1/4 is equal to log base 3 of x. Okay, so now we want to simplify those insides. So 6 squared, that's pretty easy. That's just log base 3 of 36. We have to think a little bit harder about this next part because we have a fractional exponent. I want to remind you that 16 to the 1/4 power, 1/4 really just means 4th root of 16, and the 4th root of 16 is just a 2. Okay, and that's still equal to log base 3 of x. Okay, and now next up I want to deal with the fact that I have two logarithms with subtraction involved. Subtraction inside means I can write a single logarithm with division on the inside, okay? And what comes before the subtraction goes in the numerator. What comes after the subtraction goes in the denominator. And that's still equal to log base 3 of x, okay? So now I can apply the property of equality because I have log base 3 of something equals log base 3 of something else. So I have 36 over 2, that's really just an 18, and that's equal to the other inside, which is x, okay? But one thing you need to watch out for is, do you have extraneous solutions, because this was a logarithmic equation. So go back to the original equation, locate your variables. All right, there was only one variable involved, and if I plug in an 18 right there, that's not going to give me any issues because we can't have a negative or a 0 inside of a logarithm, but any positive number is all set. So this works out. So that means the final answer to this equation is x equals 18. All right, let's take a look at another one. So for problem number 12, we have log base 2 of x plus log base 2 of x plus 3 is equal to 2. So there aren't any coefficients involved, but the first thing I see is this plus sign. Plus in between logarithms means I can write a single logarithm, so I have log base 2 of, and I can turn it into a product. So the first thing times the second thing, x times x plus 3. Okay, so that's the condensing step. All right. Now I want to simplify that a little bit further, so I'm going to make this log base 2 of x squared plus 3x. All right, so distribute on the inside, simplify that product down a little bit. Now normally we would have a log equal to a log, but we don't have that here, so I can't use a property of equality, but what I can do is I can rewrite this in exponential form. So the log has a base of 2, which means the exponential has a base of 2. And what the logarithm is equal to, well, that's the exponent. And we can set that equal to the inside expression. So now we have a quadratic equation to solve, because 2 squared is really just 4. So I'm going to replace the 2 squared with a 4. So I have 4 equals x squared plus 3x. And we know that the best way to try to solve a quadratic equation is to set it equal to 0 and either solve by factoring or solve with a quadratic formula. So I've got 0 equals x squared plus 3x minus 4, and that does in fact factor. Factors of negative 4 that add up to 3 are positive 4 and negative 1. So that means I have two solutions, or two potential solutions I should say, to this equation, negative 4 and positive 1. And I say potential because we need to go back to the original equation and verify that these values will not give us negatives or zeros inside of the logs. So the original insides were x and x plus 3. And if I plug in negative 4 in for x, I get a negative 4 here and a negative 1 here. And that's not allowed to be inside of a logarithm. We can't have a log of a negative number. That's one of our domain restrictions. So negative 4 is going to get discarded. It is not a feasible solution. Okay? But we need to make sure that x equals 1 is going to work out, because there's no guarantee that it will. So if I plug in x equals 1, I would have a 1 here. And if I plug in a 1 here, 1 plus 3 would give me 4. Well, those are both positive numbers, so that works out. So I do get to keep the x equals 1. So the final solution to this equation is just x equals 1. Okay? But I want to remind you that you need to be showing all the possible solutions, and then if something is extraneous, if it needs to be discarded, go ahead and discard it after the fact, but show that that -4 in this particular case was still a possible solution, but it ended up being an extraneous solution. Okay, so the final solution is just x equals 1, and that is solving logarithmic equations by first using properties of logs.